Hey everyone, so in this video what we're going to do is we're going to go over the last problem on the merit worksheet from today. So this is the, hang on, sometimes my computer's weird, there we go. So this is the selectivity or calculating the selectivity problem here. So that is what we're going to focus on. Now, whenever we do one of these selectivity problems where it's asking for these selectivity values, we're actually going to use somewhat of a table to go ahead and figure this out. So I'm going to go ahead and draw that table. So we're going to have a row for the statistical. I can spell. We're going to have a row for the statistical. We're going to have a row for the experimental. And then we're going to have a row for the selectivity. Now, let's go ahead and actually turn this into a table now. And what happens is we're going to have two columns at the very top. So we're going to have two different things that we're comparing here. Now, the things that we are comparing are always the, the substitution of the carbons. So in this case, we're comparing tertiary carbons versus primary carbons. So I'm going to go ahead and write that. We're going to have tertiary versus primary. Now what happens is what we're doing here is we're going to have to find the statistical and we're going to have to find the experimental, and that will allow us to calculate the selectivity. Now the selectivity, which I'm going to abbreviate as SEL, is equal to the experimental divided by the statistical. So let's go ahead and get started here. And to get started, what we're actually going to do is we're going to start out by calculating the statistical. Now this is the easiest part to calculate. What we're going to do is we want to just count the number of positions where halogenation can happen. So what I really mean by that is we want to look at the hydrogens. So we know that everywhere there is a hydrogen, we can have a radical halogenation reaction. So in this particular case, we have 6, so 1, 2, 3, 4, 5, 6 tertiary hydrogens. So the statistical here is going to be 6. Now with the primary carbons, it's a little bit more tricky because we have 3 hydrogens on each primary carbon. So here the statistical is actually going to be 3, 6, 9, 12, 15, 18. And it's 18 because there are 18 primary hydrogens. So it's important to note that we're not calculating or we're not counting the number of primary carbons. We're counting the number of primary hydrogens, which is why it's 18 as opposed to just the 6. So then that's all we have to do for our statistical. For our experimental, what we're going to want to do is we're going to want to plug in these percentages. So these percentages are our experimental. So it's 46 for the tertiary carbon and then 54 for the primary. Now with this, we don't have to convert these into decimals. We just want to directly plug in that percent. And then to find the selectivity, we're going to take that experimental divided by the statistical. And I definitely cannot do this in my head. So we're going to go ahead and pull out a calculator and do some math. So we're going to take 46 divided by 6. So in this case, we're going to get approximately 7.67 as our statistical. Over here, we're going to get approximately 3 as our statistical, which is good. And then what we're going to do here is we want to kind of get a like 1 to something ratio. So we want to kind of simplify this ratio. So right now our ratio for the selectivity is tertiary to primary. It's going to be 7.67 to 1. So what we're going to do, or not to 1, excuse me, to 3. So then what we're going to do is we're going to try and kind of make this a little bit nicer of a number. So what we can do is we can take and divide both of these sides by 3, like this right here. If we take 7.67 divided by 3, we're going to get like 2.5 or something like that, I think. Yep, we'll get 2.5. And then 3 divided by 3 is 1. So then this is a 2.5 to 1 ratio. So hopefully this helps. Hopefully this makes sense that we have a selectivity for, it looks like the tertiary position over the primary position. And you kind of want to follow this method anytime you go ahead and do radical halogenation. So I hope this helps. I hope that this was beneficial. And I will see all of you soon.